All right, we're officially recording. Hey everyone, welcome to presentation for this is for Big Data Analytics course at Columbia University. I'll be presenting. I'm Alex on behalf of myself and my colleagues Amira and Tanvi. So we created an application that used the Spotify API and did some pretty cool music genre classification stuff. So there's our nifty logo, a little bit of a throwback to the early days of Apple in the early 2000s, the original iPod design. So jumping right into it, the overview of the project is basically we want to do genre classification for individual tracks. The current Spotify API can only classify based on artist, which might not be the most useful thing because you could have artists, and we'll mention this in a minute with the next slide, that across their discography are very, very versatile. So musically and tonally might sound extremely different from album to album or even track to track. So being able to capture the genre of individual tracks is really useful. And we've seen this with Spotify Wrapped, which took over social media just 2 weeks ago, the beginning of December. Um, People took to Instagram and Facebook sharing their top genres that they like to listen to. But how does Spotify actually do this? We suspect that they have some secret sauce under the hood, probably trade secrets that they aren't willing to give everything out with the developer API. But our team reverse engineered that magic a little bit and was able to recreate the process. So another benefit of this is we can predict just from the name of the track only. So we can use the Spotify API search feature to go and look up the highest returned value for that specific track. Like let's say we look for All I Want for Christmas Is You. It better get the Mariah Carey version and not the Michael Bublé version, right? Because that's the one that people want to listen to. So we go and fetch that, and we can go and actually parse the metadata for that song. We don't need the MP3 file like pretty much every other classifier on the market right now. We can just look at the features that Spotify provides, and we can classify based on that, which is pretty cool. And embracing the world of big data, you're not always going to have access to an MP3 file for a song that you want to process. Uh, Music streaming is taking over more and more. It's less and less common to actually have tangible personal copies of your music. So just being able to look from the name of a song is really useful. So let's get into sort of the business value. And I did touch on this a second ago, but maybe you have an artist that's extremely versatile. So we use one of my favorite examples, Taylor Swift. She sounds tonally different across her albums. And we'll give the example of if you like Ronan from uh, Red Taylor's version, which is an outstanding album, just came out last month. What genre is that song? The Spotify API would only be able to tell you the different genres that Taylor Swift is linked to. So that's quite a big list: pop, country, folk, rap, and plenty more. So you can see Red Taylor's version is going to sound a lot different than, say, Reputation from 2017. So while they are the same artist, we need higher granularity. So being able to classify on the track level is really, really useful to us. So how did we actually do this? Well, since Spotify doesn't provide those labels, but maybe they do other things, we can use that recommendation feature that we can look at the seed genres that they support. They support 126 different ones. We picked 73 that we could get sort of clustered together in this hierarchy you see, and we could also get a sufficient number of them. So we went and looked for recommendations for genres. You could get a batch size of up to 100 from Spotify. We spammed their server over and over and over again, throwing away repeat songs until we got about 500 for each subgenre. And this resulted in the balanced data set that you see over on the right. So all the 73 subgenres, we, as a naive approach, link them up to one we call supergenre. So you could think of like black metal, death metal, hardcore. We call those hardcore. Those are all, we could clump them together. And that's a little bit of a simplification, and we'll get into that in the analysis section. So you could take the example of punk rock, which we have listed under alternative. That would be a miss if we called it rock. But in actuality, maybe calling it rock versus alternative, um, maybe both of those labels could be correct. But how would we know that? So that's where it gets a little bit interesting. But just for a first pass, just to make it easy and we can visualize this nicely, we have that sunburst diagram on the right, and you can see one subgenre is going to link to one supergenre. So one-to-one mapping for now, just to keep things simple for classification. So what features are we using? Well, Spotify has a couple of different calls that you can use for if you know the Spotify track ID of a song. So once you have that identifier, you can go to them and fetch track information. So that might look like the year that a track was released, and that actually could be really distinguishing. Like rock music is a lot more likely to be released in the 80s, as you would expect. You could use popularity too, which is a relative index. I think it's 0 to 100. So 100 would be everyone's listening to the song, it's top of the top charts, and 0 is it's really niche music that almost no one's listening to. So we like our classical music section versus our pop section. You'd expect classical to be lower. A lot less people are listening to Mozart than Ed Sheeran in 2021. Maybe that could be distinguishing too. And although we don't have the MP3 file, Spotify is pretty keen to not hand out the music that they're trying to stream. They don't want to lose their customers or have someone use their open source API and recreate their great application. But maybe they do provide timbre and pitch. So those we can use Spotify's audio analysis API call, which can show us which notes are prevalent and which timbre sounds are prevalent. So they break this down by something called a segment, which is a uniquely sounding part of a song. And we average this over the whole song so we can get the consistent 1/12 vector for pitch and timbre across everything. But these are a couple of the features that we're using to train the model. So this is what our architecture looks like. Like I mentioned before, we go to Spotify with a list of genres, we get recommendations, build our data set, go collect the features for those, and then now we've created this data set that we have our subgenre labels from when we go and ask them for recommendations, but we also have the features. So we've created this labeled data set, we train the machine learning model, and then as a stretch goal down at the bottom, if we get a front end that somebody puts in a string into a JavaScript app, and we go and do that same process, get those same features for the highest ranking song that we can find, can we predict the genre based on that alone? So this is kind of the high level overview. In green, you've got scripts. In blue, you've got data storage in cloud computing. And purple would be an application for the user. So how did this thing actually do? Well, as a benchmark, humans generally do like 70%. And this is a lossy data set, right? Because we don't have the actual MP3 file, but we can do pretty good. With gradient boosted trees, we were 62, 63%. You'll notice the easy listening category is not in the confusion matrix. We'll get into that in the analysis. We ended up throwing that away because of some data processing and analytics that we did. But you'll also see alternative and rock, as you would expect, have some overlap in the confusion matrix. So it's not perfect, but it can get pretty good, especially like classical music, 88%. That's excellent for test. And then dance, 76. That's pretty high. And then the training set was, as you would expect, even better. So getting into what breaks the algorithm. Well, Mumford and Sons does a pretty good job of that. Blink 182. We noticed when we were analyzing the data sets that we had, some tracks were actually recommended across all different types of subgenres. So maybe in our guitar subgenre, that the data set that we built for that subgenre, we would get the same track from Blink 182 as maybe we got in grunge and alternative and emo and study, which we linked to something totally unrelated from those. So this is where it starts to break down. And rather than look at this as a negative, we actually use this to our advantage to reveal some underlying connectivity between the subgenres. So if a track was recommended for subgenre A and subgenre B, we can infer a little bit of relationship between those two subgenres. And if we look at all the tracks that were recommended over and over again across different subgenres, which was a totally not trivial number, there was like hundreds of them, we can start to piece together a little bit of the patterns. So as a naive guess, maybe the underlying structure would look something like this, where pop, dance, jazz, maybe these are connected by breakbeat, musical and pop. Maybe you'd have pop film filling that gap between rock and country, maybe like rockabilly. So we would expect that there's these underlying subgenres that sort of fit between one and more than one supergenre. But we would expect that other ones would be distinct. So like show tunes, we'd think would be way off on its side. And then like Latin music, most of those would be on their own too. But like the example of alternative rock, maybe that would equally fall under rock and alternative. So we set out to go find more representative supergenres. Maybe we have to throw away this model completely, but we also want to find the suspects that are pretty bad. So the highly interconnected subgenres. So how we do this was we created an algorithm called the interconnectivity rank. So think the opposite of PageRank, the Google algorithm, where you want to find the web page that is most interconnected, most cited. Instead, maybe the most overlapping subgenres um, provide the least information. So maybe we want the lowest connected, the lowest rank. So we could do a reverse sort by value and figure that out. So maybe for every single subgenre, we create a node in a graph, and for every subgenre pair, maybe that would be an edge, and we could look to see which subgenres appear, or those tracks that are listed for subgenre A, subgenre B, and subgenre C. Maybe we'd create an edge between subgenre A and subgenre B and subgenre C. Save those off, and we could see which subgenres appear with the most collisions. So we can sort of think about it like this, and that actually leads to some interesting visualization. This is the true underlying structure where you have a bunch of songs that are super interconnected and the ones that are more on the edge. So like Latino, K-pop, black metal, these are all very distinct. And then there's other ones that aren't even listed on this because they were off on their own clump, like some of the J-pop, J-rock, those were off on their own little island. But you have the usual suspects like blues, rock and roll. These are the ones that we would expect, but maybe like sleep. We didn't expect that to be so interconnected, but yet, here it is. So ranking them, the top 10, you've got chill, study, and sleep rounding out the top 10. Interestingly enough, that was comprising our easy listening category, so that's why we ended up throwing that away. We figured that those provided the least amount of information, but like intentionally vague ones like guitar, party, acoustic, those are unsurprising offenders that make an appearance here. So where do we go from here? Well, we can take a look at the most interconnected subgenres and throw them away. So get rid of those top 10, and this is the updated hierarchy. And we can stick with that super genre, subgenre, one-to-one mapping as before. And this is where we got that 63% accuracy with the training set. Or I mean with the test set, we updated the sunburst diagram to reflect that. But maybe we could go a little bit beyond that. We're really kind of onto something with this interconnectivity rank. So maybe we could improve this even further. We ran out of time to implement this, but we did come up with a new algorithm that actually would help us to classify tracks that maybe would fall under one or more of the supergenres. So previously, a song that was labeled as alternative, if we classified it as rock, that's a complete miss. When in actuality, maybe there's some overlap there. So we could take a look at those edges that we saved, the subgenre pairs, where the subgenres are the vertices, and you could maybe keep track of how closely related individual subgenres are. So if you take a small factor, we call it alpha, we call it it's the normalization constant. We could go from a one hot encoding label at the output and update it so that we get, instead of all or nothing, maybe like rock and alternative and maybe even hip hop would provide some value to you there too. So instead of if portraying one genre at the output, maybe we would rank the top 3 and show you the confidence for those. And this would also help us improve our accuracy too. So we can capture if there's a song that's perfectly 50-50 between two super genres, we can make a 0.5, 0.50 for all the other elements label for that. So again, ran out of time for this, but this is a really, really interesting idea. And then last thing, another stretch goal, we built a front end for being able to implement that JavaScript app, which was the stretch goal. But we did also run out of time to connect that to the back end. But this is the visualization of what that would look like. So that's the project. Thanks for listening. You could follow that link to check it out on GitHub. And at this point in time, we'd usually ask for questions, but since this is asynchronous, feel free to add me on GitHub and send your questions there. But thank you for listening to the presentation.